Welcome to physics class. In this video, I'll be solving two different questions on angle between the two acting force or angle between two force or two vector. So if you haven't watched my previous video, that is the explanation on two vector acting at a particular angle to each other, kindly pause this video now and go back and watch it. So in this video, I will be solving two different questions on scalar and vector quantity. Or let me just say, I will be solving two questions under the aspect that has to do with angle between the two acting force. Now, considering the first question, an object is acted upon by two forces, 3 Newton and 5 Newton. Let's say our force F1 equals to 3 Newton, right? And our force F2 equals to 5 Newton. Inclined at angle 60 degrees to each other, right? That is, both are acting at angle 60 degrees to each other. If the object is moved through a distance of 6 meters, that is, if the object is moved through a distance of 6 meters by the resultant force, F, which is R, we don't know our resultant force. That means we have to calculate for the resultant force. The work done is, now we are also asked to calculate for the what? The work done. Given the options A, B, C, D, and E. So the first case is that since we are having two vectors in this case, which is our force F1 and force F2, both are acting at angle 60 degrees to each other. And first thing we need to do is that if we have two vectors acting between angle to each other, the angle can either be acute angle or it can be obtuse angle. And talking about acute angle, they actually act between angle 0 degree to 90 degree. They are what? Any angle that is between 0 degree and 90 degree, they are known as acute angle. And any angle that is between 90 degree and 180 degree, they are taken to be the what? Obtuse angle. Right? So what actually happens in this case is that since the angle to which both our vector A and vector B are inclined is taken to be what? 60 degree. Right? So that means it falls on our acute angle, and the diagram is going to be something like this. Right? Since it is 60 degree, it's going to be something like this. Exactly. So we call this 60 degree, right? But according to the characteristics of parallelogram, it says that the opposite sides are equal, the opposite sides are parallel, and also the opposite angle are equal. But one major factor you guys need to note is that if you are talking about parallelogram, that means we're talking about acute and also obtuse, because both acute and obtuse can actually form parallelogram. Now, let me just say imagine a line here, since the side of this side must be equal to what? This side. Let me just imagine a line here, right? If I imagine a line here, right, then I imagine another one that joins to this, right? So as you can see, this is actually a parallelogram in which these sides are what? Are equal, and the angle that is the opposite angle, which is this and this, must be equal. In this case, it just shows that if this is 60 degree, this also must be 60 degree, right? But this angle, I don't know this angle, and likewise I don't know this angle, right? So to find this angle, since according to the properties of parallelogram, which says that all angle must be equal, let me just say the sum of all the angle must be equal to 360. That means if I call this A, I call this B, I call this C, and I call this D, that means A plus B plus C plus D must be equal to 360, right? But since in this case my A and B, my A and C are opposite angle, but they are equal, since I'm having A and C here, which is 60 degree, right? 60 degree. That means I'm going to represent my B and D with a letter since both of them are opposite to each other. That means let me just call B and D as my what? X. In this case, I will just have A plus X, right? Plus, let me just say 60 degree plus X plus 60 degree, right? Plus what? Plus X again equals what? 360 degree. So here I'm going to have 120 degree plus 2x equals to 360 degree, right? So here I'm going to have it to be 2x equals to 360 degree minus 120 degree, exactly. So here I will be having it to be 2x equals to 360 degree minus 120, that should give me 360 minus 120, that's 240, exactly. I'm having 240. Then I'm going to go ahead and divide this side by 2. Then I'm having it to be x equals to 240 divided by 2, which is what? That's 120. It shows that if this side is 120 degree, then this side also will be 120 degree. But the first thing I need to do is that I actually need to go for the resultant force, and my resultant force is taken to be the point at which my vector 1 and vector 2 they intersect each other. The point at which my this force F1 intersects F2, right? Intersect S2 is my resultant force. So in this case now, my F1 come both actually intersect at this side. Then this is going to be our resultant force. This side is going to be our resultant force, which is R. Right? So one major thing I need to consider is that this side, the angle of this side is actually 60 degree. But here is something, I can call it my beta, right? And here is something which is my what? Alpha. So I'm going to consider A, C, and D. I will consider my angle A, C, and D. Considering angle A, C, and D in this case, I'm going to have it to be something like this, right? I'm having it something like this. Then I'll be having it to be, sorry, I think that's exactly. Hope you guys are just, hope you can see. So I'm having it to be this. Here I will be having angle A. I will be having my B here. I will be having C here. But here, this line, which is this, is actually my what? My resultant force. But this angle is taken to be what? 120 degree, right? This side is actually what? My alpha. So now, going ahead to calculate for the resultant force. To calculate for the resultant force of a parallelogram, I'm going to use cosine angle, which is r squared equal force F1 squared, right? Plus force F2 squared, then minus 2F1, F2, then cos B in this case. B, cos B, because this is my angle. The angle I'm having here is B. So now, let's go ahead and calculate it. Our r squared is going to be equal, what's our force F1? Force F1 is taken to be, that's F1 in this case is 3, right? That's 3 squared plus F2 in this case is taken to be 5 squared, then minus 2 into bracket 3 times 5, then cos 120, right? Then I'm having r squared to be equals to 9 plus, that's 25. 9 plus 25 minus, this should give me 30. Then cos 120. Cos 120 is what? That actually is multiply minus 0.5. So here I'm going to have it to be r squared equals to, that's 9 plus 25, which is 34. Then minus 30. This actually, that was minus 30. Minus 30 times, that should give me 15. Multiply minus 15, minus 0.5. That's actually 15, exactly, plus 15. Then here I'm going to have r squared to be equals to 34 plus 15. That's 49. Then I'll have my roots, r to be root of what? Of 49, which is actually equals to 7. So since my resultant force r is equals to 7, right? Which is 7 Newton. The question now says, I should calculate the work done if the resultant force move an object through a distance, which is what? 6 meters. Then my work done equals to what? Force times distance, right? So in this case now, I'm going to have my work done to be equals to what? 7 multiplied by what? 60 into bracket Newton meter, right? Then I'll have my work done to be equals to what? That's 42 Newton meter. Right? So in this case now, my work done, my option, the right option here will be what? Option A, which is 42 joules. Newton meter is also known as joules since we are dealing with work done. So our right option is actually option A. Then let's move to question 2. So question 2 in this case, assuming our force F1 is 3 is 10, okay, force F3 here is 10 Newton and force F4 is 12 Newton. We are asked to find the resultant force R, and at the same time, let me just include direction in this case. So it's very simple. So what we are going to do actually is that since this, we are going to assume this side to be A, call this side the B, we call this side as C, right? And here we are asked to calculate for the resultant force. We still go ahead and use our cosine rule, which says R square equals to, in this case we are having force F3 square, right, plus force F4 square, then minus 2 F3 F4 cos what are we going to use here now? Is it going to be cos B or cos C? Actually, it's going to be cos C, since we are given 45 degree here, and this is where our imaginary line falls. So let's go ahead and calculate the resultant force. Here we are going to have to be R square equals to F3, which is 10 squared, plus F4, which is 12 squared, then minus 2 multiply by 10 multiply by 12, right? Then cos 45 degree. So here we are going to have to be R square, which is equals to 244. 10 square is 100 plus 12 square, which is 144. So minus, here you are going to have it to be, everything here is 240 multiply by cos 45, that should be 0.707, right? So here I'm going to have R squared to be equals to 244 minus, multiplying this together, we're going to have it to be 169.70, right? So here we are going to have our R squared to be equal 74.29, right? Then our R will be equals to roots of 74.29. We're going to have it to be 4.29. We're going to have it to be R equal 8.62 Newton. So since this is actually our resultant force, which is R, then what's going to be the direction if resultant force R is equal to this, right? So now let's go ahead and calculate for the direction. To calculate for the direction in this case, we are going to have it to be R over sine R. This R is in between angle A and B, right? Then AB over sine C, which is R over C, sine C now, right? Equal to F3, right? Divided by what? So in this case, that will be F3, which is our F3, acting towards this side, which is what? Our sine A. Right? So in this case, I'm going to have to be AR resultant force is what? That's 8.62 divided by what? Sine 45, right? Equal, that's our F3, which is taken to be the what? Which is taken to be 10 divided by sine A. In this case, sine A is unknown, right? So in this case now, I'm going to have it to be 8.62 divided by sine 45 equals to 10 divided by sine A, right? So in this case, I'm going to have it to be sine A multiply by what? 8.62 equals to 10 multiplied by sine 45, right? Then I'm going to have my sine A to be equal 10 multiplied by sine 45 divided by what? 8.62, right? So here I'm going to have it to be sine A to be equal, that's actually, press everything on calculator, let's see what's going to be. Then I'm going to have it to be, that's 0.8203, right? Then here I'm going to have to be A equals to sine inverse of 0.8203. Sine inverse is also the same thing as dividing both sides by what? By sine. So here I'm going to have my A to be equal 55.12. It shows that this angle here is 55.12. My A actually, I represent as A because it's the angle of what? Of A. We can call it an alpha. Can call this alpha. Let me just put alpha here. So I'm having the angle towards A is alpha, which is 55.12. Right? So I think that's all about direction and also the what? The angle. So if you find this video helpful, kindly click on the subscribe button and do well to share it with your friends. And don't forget to click on the notification button so that you get notified whenever I drop a new video. Thanks for watching.